Hey there, this is John Livingston. In this lesson I'm going to show you that understanding the European standards isn't as hard as it seems at first. There are two parts to the European EMC standards, emissions and immunity. This lesson is about getting familiar with some of the history of the various standards agencies and focusing on decoding the emissions standards specifically. Getting through that will make the next part, which focuses on immunity standards, much easier. But that'll be covered in the follow-up lesson. Just like in the US, the European Union controls electromagnetic emissions from digital devices. In terms of understanding European standards, most of the technical information that we've already covered in the previous video about the FCC still applies. So the limits are pretty simple to understand when you use the FCC limits as a base for comparing them to. The tricky part with the European standards is the many different committees and standards bodies involved. We'll briefly cover some history and a few prominent committee names, so hold on there and don't let your eyes glaze over. I need to talk about those first because you'll see the various standards numbers a lot, many of which are based on these committee names. The many different standards numbers can be a source of much confusion if you don't understand where the names come from, because otherwise it's just like trying to memorize a bunch of cracks on a wall. If you can understand how the standards bodies are connected, you'll clear up a major hurdle in your understanding of EMC in the nuclear power industry. So now moving on to the history, the European EMC standards are generally based on those developed by CISPR, which is a committee of the International Electrotechnical Commission, or the IEC for short. CISPR is an acronym for a French name which, when translated, means the International Special Committee on Radio Interference. The committee was first formed in 1934. The IEC is a non-governmental standards body that was founded in 1906. It was instrumental in establishing the international use of various units of measurement like the Weber, the Gauss, and the Hertz. Its headquarters is in Geneva, Switzerland, and membership consists of 82 countries, which is about 42% of the world's total countries as of 2014. The US, the United Kingdom, Germany, France, and Australia are just some of its member countries. The US, for example, is represented by ANSI, and national electric equipment companies are represented on various committees of the NEC by groups like NEMA. Moving on from the IEC, next is CENELEC. It is a non-governmental European standards body. This is a key point, so just to be clear, CENELEC, a European standards body, is contrasted here with the IEC, which is an international standards body. Now, CENELEC works closely with the IEC. The European Union has recognized CENELEC as an official standards body. And what that means is that when European Parliament issues directives, such as the EMC directive that makes it a legal requirement that digital products comply with EMC standards, it points to standards issued by organizations like CENELEC that form the basis for product compliance. It seems confusing, so it's probably best to think of the European structure analogously to the US structure. In the US, the FCC writes the rules and regulations governing EMC compliance. They also developed the limits, and early on they even developed their own test procedures. Now these days they endorse C63.4, which is an EMC measurement procedure that's published by ANSI, which is a non-profit private standards organization in the United States. To compare this with Europe, the European Union makes EMC compliance the law by passing the EMC directive. To quote directly from the 2004 directive, it says that the design and manufacture of equipment is subject to essential requirements in relation to electromagnetic compatibility. Those requirements are given technical expression by harmonized European standards to be adopted by the various European standardization bodies, European Committee for Standardization, or CEN, European Committee for Electrotechnical Standardization, or CENELEC, which we just covered, and European Telecommunication Standards Institute, or ETSI. So all that means in plain English is that the European Union bureaucrats delegate the actual technical standards writing to engineers and scientists employed by non-profit bodies like CENELEC. CENELEC in turn works with international organizations like the IEC and tends to adopt its standards as its own. CISPR 22 is an example of such an emission standard that contains both limits and measurement procedures. As I'll explain in a moment, it's been adopted by the European Union. So if you think of the European Parliament as being similar to Congress, CENELEC is somewhat similar to the FCC in terms of establishing what constitutes compliance with the law. A critical thing to be aware of when doing EMC compliance in the nuclear industry is the existence of European and international generic and dedicated product family standards. An example of a dedicated product family is that of information technology equipment, or ITE, which is specifically covered by CISPR Publication 22, or CISPR 22 for short. Examples of other specific international product families are low-voltage switchgear, variable frequency drives, and even instrumentation and control in nuclear facilities. Any product that isn't covered by a specific product family is covered by the generic standard. So no electronic device can escape EMC testing because the generic standards act like catch-alls. An example of such a generic standard is IEC 61000-6-3, which covers radiated and conducted emissions for residential, commercial, and light industrial environments. The generic standards usually point back to specific standards for test procedures, but provide their own set of limits. IEC 61000-6-3, for example, refers back to CISPR 16 for the procedure for measuring conducted and radiated emissions, and CISPR 22 for the procedure for measuring conducted emissions from Ethernet ports. The European standards bodies like CENELEC may adopt the international IEC standards. They will give them different names when they do so. So as was just discussed, CISPR 22 is the standard for information technology equipment that contains the conducted and radiated emissions limits and measurement procedures developed by the CISPR committee. But when it's adopted by CENELEC, it becomes EN 55022. The EN designator, which stands for European norm, alerts European Union member states that it's a standard that's been officially adopted by the European Union. The European Union member states are under no obligation to enforce or adopt international IEC standards, any more than they are to adopt U.S. requirements issued by ANSI or the FCC. They're only obligated to adopt European ones. So for the IEC standards to become enforceable in Europe, they must be adopted as European standards, or ENs. The content of the EN standards may be identical to that of the IEC standards, but the names are slightly different. And it's here where the confusion begins. The NRC endorses the IEC standards in Reg Guide 1.180 as acceptable for demonstrating EMC compliance, but actual products and devices are tested to the EN standards, because those are the ones legally enforced in the countries they're being sold in. In fact, there is no IEC certification process or stamp. The IEC even includes such a statement at the beginning of its standards. Such a typical statement is this one here that says, the IEC provides no marking procedure to indicate its approval and cannot be rendered responsible for any equipment declared to be in conformity with one of its standards. So here we have a situation where the IEC standards can be referenced and endorsed, but no product is actually tested to the IEC standard because there's no official IEC certification process. So products are tested to the EN standards instead. That's why you will see both IEC 61000 type standards and EN 61000 type standards when studying EMC compliance in the nuclear industry. I don't think the relationship between these slightly different naming conventions is ever adequately explained to my liking, quite honestly. This gap leaves most engineers in the dark when trying to figure out whether a product will meet the EMC guidelines issued by the NRC. Products that meet the European Union's EMC directive are stamped with the CE mark. You've probably seen this icon before. It's on many products even sold in the United States. Just as U.S. regulations extend throughout all sectors of the economy, the CE mark shows up from anything ranging from children's toys, nasal spray, and laptop power supplies. The CE mark means that the device is in conformity with the relevant European directive. For electric equipment, this usually includes the EMC directive, which means even though it may not be information technology equipment, it has probably had its emissions tested to one of the CISPR limits. Now I'll come back to that shortly. Before moving on to a discussion about the limits, let me give you a real-life product example. ABB makes an insulation monitoring relay. You can see a picture of it here with the CE mark stamped on its casing. If you look at the relay's declaration of conformity, you'll see that it's been tested to, among other things, EN 61000-6-3. Actually, it's the German version of EN 61000-6-3, as denoted by the DIN in its name. Now, if faced with installing this device in a nuclear power plant and trying to decide if it meets the NRC's requirements, the electrical engineer would have to determine whether this product, which has been tested to DIN EN 61000-6-3, meets the requirements of IEC 61000-6-4 that are called out in Reg Guide 1.180. For the uninitiated engineer, this is, quite honestly, a kind of nightmare scenario, but I'll help get you through it. For now, let's leave history behind and move on to the actual limits. I'm going to first discuss the conducted and radiated emissions limits for the CISPR 22 and EN 55022 standards, which, if you'll remember, are the international and European standards that cover information technology equipment, things like computers. Then I'll move on to the generic standard for any equipment that falls outside of the specific categories of product families defined by the IEC. First, a quick word of comparison to the FCC. I discussed the details in a previous video, so this is just a brief review. Just like the FCC, the CISPR 22 standards recognize Class A and Class B devices depending on whether the equipment is used for industrial and commercial applications or residential ones. Second, the measurement methods are essentially the same. A LISN is used to measure conducted emissions, and either an open-area test site or a semi-anechoic chamber is used to measure radiated emissions. Unlike the FCC, the measurement distances for both Class A and Class B radiated emissions are established at 10 meters instead of 10 meters for Class A devices and 3 meters for Class B. But similar to the FCC, the inverse distant method is allowed for adjusting the limits according to different measurement distances than what's prescribed. For all conducted emissions measurement methods, just as in the previous video, I've gone with the quasi-peak limits. So first, let's look at the Class A limits. From 150 kHz to 500 kHz, the limit is 79 dB microvolts, and from 500 kHz to 30 MHz, the limit is 73 dB microvolts. These are identical to the FCC Class A conducted emissions limits. As discussed in the previous lesson, Class B limits are more stringent than Class A limits because of the residential versus industrial environment. For Class B devices, from 150 kHz to 500 kHz, the limit decreases from 66 dB microvolts to 56 dB microvolts. From 500 kHz to 5 MHz, the limit is 56 dB microvolts, and from 5 MHz to 30 MHz, the limit is 60 dB microvolts. Again, these are identical to the FCC Class B limits. The two different emissions envelopes are shown on the screen. The Class A limit is shown in red on the top, and the Class B in green on the bottom. You can see how the Class B limit is more restrictive than the Class A limit. Now let's take a look at the radiated emissions limits. From 30 MHz to 230 MHz, the Class A radiated emission limit is 40 dB microvolts per meter. From 230 to 1000 MHz, the limit is 47. For Class B devices, the limit from 30 MHz to 230 MHz is 30 dB microvolts per meter, and from 230 to 1000 MHz the limit is 37. The two different emissions envelopes, just as before, are shown on the screen. Unsurprisingly, the Class A limits are shown in red on the top and the Class B in green on the bottom. Next, I want to look at the general emissions limits of the international and European standards. The International Generic Emissions Standard for residential, commercial, and light industrial environments is IEC 61000-6-3. The equivalent European standard, which is derived from the IEC standard, is EN 61000-6-3. This generic standard doesn't distinguish between Class A and Class B equipment like CISPR 22 and other standards derived from it do. It only has one set of limits because it considers all equipment tested under it of the same class. Now, I don't need to go back through the frequencies and the numbers. All I need to say is that the conducted and radiated emissions limits called out in the generic residential and commercial standard are the same as those for Class B devices. So what about Class A limits? Is there an analogous generic standard that treats all equipment tested under it as equivalent to Class A devices? Well, of course, the answer is yes. IEC 61000-6-4 and its European equivalent is for equipment used in standard industrial environments as opposed to commercial and light industrial, called out by 61000-6-3. The 6-4 generic standard uses the Class A CISPR 22 limits for conducted and radiated emissions. Now let's go back to the dilemma posed by my example of the insulation monitoring relay. It complies with EN 61000-6-3. The NRC requires compliance with IEC 61000-6-4. The question asked was, does the equipment as tested comply with the NRC's emissions guidance? Now, looking at both sets of limits on the screen, the answer becomes obvious. Yes, the equipment complies because the limits of EN 61000-6-3 are more stringent than those of IEC 61000-6-4, and the relay meets the more stringent limits of the 6-3 standard. Now, this isn't the whole picture, and the NRC places some caveats on the acceptability of the IEC standard, but generally speaking, this gives you a better idea of the problems you'll need to solve and how much easier it is to solve them when you have a little knowledge about the standards. I've already shown that the FCC has harmonized its conducted emissions limits, both Class A and Class B, to those of Europe. But it's not so easy to make such a direct comparison between the CISPR 22 radiated limits and the FCC's. That's because for some frequency bands, the limits are more or less stringent, depending on which limits and which frequency bands you're looking at. The different Class A limits are shown together on the screen here side by side. Now you can see the differences. But as it turns out, we don't need to worry about these differences because the FCC accepts the CISPR 22 limits as an alternative to meeting its limits. As it's written in Part 15.109G, as an alternative to the radiated emission limits shown in paragraphs A and B of this section, digital devices may be shown to comply with the standards contained in the third edition of the International Special Committee on Radio Interference, Publication 22. Now what that boils down to is this. If any digital device has been stamped with the CE mark, then it will meet the FCC's requirements. There are exceptions, but you can take that to be the general rule. Now, let's just quickly review the highlights of this lesson. Just like the FCC, the European Union controls the limits on both conducted and radiated emissions, but figuring out what all the standards' numbers are and what they mean can be confusing. That's because most of the European standards are adopted from standards created by the IEC, which isn't affiliated with any national government. One of the most influential standards committees of the IEC is CISPR, which created test methods and procedures in its publication 22 that have been widely adopted throughout the European Union. CISPR 22 is specifically for information technology equipment, but has been adopted in the European Union under the name of EN 55022. The European Union passed the EMC directive, which regulates electromagnetic compatibility. It designated CENELEC to develop the test standards that determine compliance with the law. CENELEC liked the IEC's CISPR 22 standard enough to adopt it as its own. EN stands for European Norm, which indicates an officially adopted European test standard. Similarly, CENELEC adopted generic products test standards that are derived from the IEC's generic standards. A typical generic emissions standard is IEC 61000-6-3 for residential digital devices. The EN's version is named EN 61000-6-3. The CISPR 22 emissions limits for Class A or Class B devices are commonly used across a wide body of standards for all different products, even though a particular standard may not specifically use the terms Class A or Class B. The Class A limits tend to be used for industrial and medical equipment, and the Class B limits tend to be used for residential products. For example, devices like Sony's PlayStation 4 are tested to EN 55013, which is based on CISPR 13. EN 55013 is for the sound and television receiver equipment family, and though it measures several types of emissions associated with those specific characteristics, unintentional, conducted and radiated emissions that aren't directly associated with things like channel carrier frequencies must still comply with the Class B CISPR 22 emissions limits. This is analogous to the FCC requiring that things like cell phones have their transmitters be subject to specific rules, but then having them turned off and requiring the phone's electronics to be tested to the Part 15 EMC rules. Both the Class A and Class B European EMC conducted emissions limits are identical to the FCC conducted emissions limits. The radiated emissions limits are more or less stringent than the FCC's depending on which frequency band you're looking at, but it's really a non-issue since the FCC accepts the Class A or Class B radiated emissions limits defined by CISPR 22. When a product has been shown to pass all of the testing standards, it can then be stamped with the CE mark, which means that it's legally able to be sold anywhere in the European Union. And with that, we've come to the end of this lesson. If you found it helpful, please share it with others. Thank you.